Hello, dear student. Exercise 5.1. Question number 1. Prove that the function is continuous at x equal to 0, x equal to minus 3, and x equal to 5. So, first of all, if we have to prove we have to prove the given function is continuous at a given point, then first of all, what we have to do, as we know, limit x tending to a plus fx equal to limit x tending to a minus fx equal to f of a. This is the condition of continuity, correct? That means at the particular point, at what particular point we want to check the continuity, and their left hand limit and their right hand limit both should be same, then we can say that the given function is continuous at a given point. Now in this question, if we will see here, x equal to 0, x equal to minus 3, and x equal to 5. So first of all, you remember one thing, any polynomial function, this is a polynomial function, okay, this is, and the curve of this is, there are two ways. When we will draw the graph of this, y equal to 5x minus 3. So if we draw the graph x, y, x 0, then y equal to minus 3, and y 0, then this is 3 by 5. If we draw the graph, then it represent x 0 minus 3 and 3 by 5 comma 0. So this is nothing but the continuous curve. So automatically, whatever the point is given, this is continuous for every point. So first thing you have to remember, all the polynomial functions are continuous. Okay. Now, when we want to prove this is continuous by mathematical format, so what we have to do, fx equal to 5x minus 3. So at the particular point 0, we have to find out the value, f0 equal to 5 into 0 minus 3. This is minus 3. X tending to 0, fx, we have to find out. So in this case, left and right hand side, both if you will find out, limit x tending to 0 plus fx, and this is nothing but x tending to 0 plus this, the value is 5x minus 3. So just we have to substitute the value, and this is direct substitution, this is minus 3. Similarly, this x tending to 0 minus fx, also the value is minus 3. So if we have to check both the value are same, then definitely the function is continuous. Similarly, we have to find out the value at x equal to minus 3. So first of all, we have to find out the value at the given point x equal to minus 3. F of minus 3 is minus 18. So limit x tending to minus 3 fx. So limit x tending to minus 3. If we substitute the value, this also we are getting minus 18. Now, here left and right hand value limit both are actually, for both the given function is same. So it is not required to find out both the value. If you will find out only one also, then in that case we can write the given function is continuous at x equal to minus 3. Now third, at x equal to 5, here also the same thing. The value at the point x equal to 5, the value is 22, and 5, that is, this is representing nothing but the 5 plus and 5 minus, both, for both actually the value is coming 22. So the given function is continuous at all the points. Now examine the continuity of the given function at the point x equal to 3. This is also a polynomial function. Definitely this is also continuous. So once we will find out by mathematical approach, so f of 3 is nothing but the 17, and limit x tending to 3 fx, if we will find out, this is also 17. So limit x tending to 3 fx equal to f of 3. So function is continuous at x equal to 3. Examine the following function for the continuity. Fx equal to x minus 5 be 1 by x minus 5, and this is the condition is given x equal to x not equal to 5 and all. So in this case, the given function x minus 5, we want to, and that there are two ways, x minus 5, just we draw the graph, this is linear, and definitely this is continuous at every point. So So we have to take x tending to k fx, limit x tending to k x minus 5, that is nothing but the fk. So limit x tending to k fx equal to fk. So this is continuous at the point, the given point k. So it is continuous for every real number and therefore it is continuous. Second, B, the given function is fx equal to 1 by x minus 5. So in this type of question also, for any real number k is not equal to 5. Here x had given that x value is not equal to 5. Otherwise it is undefined. So x is not equal to 5. After that, just we have to take any number k. This is nothing but a real number. Just we have to take. So at the x tending to k, fx equal to limit x tending to k 1 by x minus 5. This is 1 by k minus 5, and f of k, once we'll find out, this is also 1 by k minus 5. So this is nothing but the limit x tending to k fx equal to f of k. So this is continuous. X square minus 25 by x plus 5. Now it is given x is not equal to 5, so we will take any number c, okay, and we will find out limit x tending to c fx, and this we have to factorize x plus 5 x minus 5 by x plus 5. This will cut, and the value, once we'll substitute any real number, this we take x tending to c, this is c minus 5. Now f of c, once we'll find out, this is also c minus 5. So both the value are same, that is x tending to c and f of c both are same, so it is continuous for every point. Now this is modulus function, and in the case of modulus function, first of all we have to define the modulus function. So x minus 5, so x is greater than equal to 5, this is x minus 5, x is less than 5, this is 5 minus x. So once we draw the graph of this one, then also we can draw, and then we can tell this is the function is, whatever the function is, continuous or not. So in this case, let the point c be any point on the real line. So c, what are the possibilities? Suppose we are taking c, so c is greater than and c is less than. So there are two only possibilities. So in this case, this is the number 5. In this number only we have to check the given function of the continuity or not. Now first case is f of c, c is less than 5, we will check. So f of c is nothing but the 5 minus c. So x tending to c, x tending to c, the value is 5 minus c. So only we have to check this value, that will give this function is continuous at all real value less than 5. So for this condition, this is true. Now for the second condition, c equal to 5. So for the c equal to 5, the value is 0 at f of c equal to 0, and limit x tending to 5 minus, the value is also 0, and that's why we can tell this is 5 minus, and 5 plus value is also, because here 5 plus the function definition is different, that's why we are taking this value. So this is also 0, so we can write x tending to c plus c minus f of c equal to, so this is continuous at x equal to 5. So c is greater than 5, so f of c is nothing but c minus 5, and f of c, there is only one value, so this is also c minus 5. So this function is continuous at greater than 5. So in this way you can find out the continuity of the given function. Now prove that the function fx equal to x to the power n is continuous at x equal to n, where n is positive integer. So first of all, fx is given x to the power n. Now f is defined for all positive integer n, and its value n is n to the power n. So limit n x tending to n fn, we can, fn value is nothing but the x to the power n. So once we will substitute in place of x, we have to substitute the value n. So this is n to the power n. Limit n x tending to n fx equal to f of n. Same way we have to substitute, this is also f of n. So function is continuous at n and n, where n is nothing but the positive integer. Now question number 5, is the function is defined. So in this type of question, continuous at x equal to 0. So definitely this is not given here. So definitely we can say that the given function is continuous At x equal to 0, it is evident that the f is defined at x equal to 0 and its value is 0. So limit extending to 0 fx equal to f, this is value is 0. So and limit extending to 0 fx equal to f0, so function is continuous. Now at the point 1 we want to check. So I'm giving you only one thing. What you have to do, you have to write like this: limit extending to 1 plus fx. So limit extending to 1 plus value is nothing but the 5. So this is directly 5, and limit extending to 1 minus fx. So 1 minus, what is the value? This is x. So limit extending to 1 minus x. So just we substitute the value here. This is 1. So right hand limit and left hand limit both are not same. So definitely this is not continuous at the point 1. But at the point 2, if we will check at the point 2, limit extending to 5 fx, limit extending to 5, this value is 5. So definitely this is continuous at x equal to 2. Now find all the point of discontinuity of the given function. F is defined. Now in this question we have to check the continuity at x equal to 2. So limit extending to 2 plus, we have to write like this. This is one statement, one step. So 2 plus, this value is 2x minus 3, this is 1. Similarly, extending to 2 minus fx, limit extending to 2 minus value is 2x plus 3. 2x plus 3. So once we will value substitute, then this is 7. So this both the value are not same, then definitely this is not continuous at the point 2. Given function is defined for all the points on the real line. Now c is less than 2, c is greater than 2, whatever the things we discussed. So f is continuous at all point x such that x is less than 2. Now, so whenever this type of question is there, so at the particular point 2, this is discontinuous. But less than 2, if we want to check, there are 3 possibilities are there. If we want to check less than, greater than, but x c equal to 2, that particular point, this is discontinuous. But c is less than 2, if we want to check, the given function definition is 2c plus 3 and limit extending to c fx equal to fc. So that's why the given function is continuous at x equal to c. So for c is less than 2, c is less than 2, the given function is there is only one function. That's why that is continuous at the particular point c is less than 2. This is the first case. So fc, this is only the single definition. That's why this is continuous when the c is less than 2. Now for the c is greater than 2, there is only one definition of the given function. Correct? There is only one definition, that is 2c minus 3. So at the point c, the value is 2c minus 3 and limit extending to c fx. Limit extending to c, just we have to substitute the value, that is 2c minus 3 and extending to c fx equal to f of c. So function is continuous at all point. Now, but at the point 2, if we will check, the function definition for the left and right hand value are different. So here the point value are different, that is 2 minus and 2 plus, both value are different. So the left and right hand value are not same. So that's the function is not continuous at x equal to 2. Find all the point of discontinuity of the function. Now we can check the given point like minus 3, this is the common point, and 3, this is the common point. So we have to check at the 2 point of discontinuity. Correct? Now, first of all, the given function we have to define, and x is less than minus 3, this value we can write here minus x, and minus 3 to 3, 2x, and x is greater than 3, this we can write 6x plus 2. Now, c is less than minus 3, the function is continuous. Okay, the function is continuous. So there is only one value of the definition, so function is continuous. Now this is the first case, c is less than -3. Case second is c is equal to -3. So f of -3 value is, this is nothing but the 6. 3 plus, now 3 plus, if you will see the definition at the 3 plus, so 3 plus is nothing but -3 plus, this is -2x. So -3 into -2, -3 plus, -3 plus value is -3 plus, x is less than -3, -3 plus, so -2x. Oh, sorry, -3 minus, here the value is -3, that is the left hand side value, the function definition is this, and when we substitute, this value is getting 6. Now 3 plus, the continuity, the function definition is -2x, and in this case function value is, so all the at the particular point left hand limit and right hand limit at the particular point x equal to -3 are, all values are equal, so this is continuous. And third, -3 to 3, there is only single definition, that is -2x. So at the particular point, the value is -2c, and c, the value is -2c, so the function is continuous. So case number 4, if we check c equal to 3, then at the c equal to 3 we can find out two values, that is whenever the equal value we have to find out, and then in that case we have to check the definition. We have to check the definition of the given function. At c equal to 3, the function value is nothing but the x equal to 3. This is the value. So 3 minus, this is the 3 minus, that is the value of the definition of the function is -2x and -6. 3 plus, the value is 20. So this both value are different. That's why the function is not continuous at x equal to 3. So you can say that at the particular point x equal to 3, the value, both value are not same. So this both the value are not same. This 3 minus value is coming -6 and 3 plus value is coming 20. So this both value are not same. So this is not continuous at the particular point 3. So always remember one thing. When there is two defined value, two function definition is there at the given point, so that is the most important thing, and we have to check there. Now suppose only single value or definition is there, like c is greater than 3, so fc value is this only, and after that x tending to c, so we will find out then the value is same. So in this case the function is definitely that is continuous. Now find all value of discontinuity of, now in this question x is equal to 0. Now x is not equal to 0, there is two possibilities, either greater than 0 or less than 0. So how to find out? Limit x tending to 0 plus fx. So x tending to 0 plus, what is the definition of mod x? That is x by x when x is greater than 0. So this value is 1, and limit x tending to 0 minus fx, if we will find out, then this is minus x by x, this is -1. So from here only, if this is 1 and this is -1, so here only the value is not equal, that is left hand limit is not equal to right hand limit. So we can say that the given function is not continuous at the given point. So this is written in this way. First of all, we have to define the given function. When x is not equal to 0, then x is less than 0 and x is greater than 0. This is the two different value, and at x equal to 0, the given function value is 0. So based on that, case 1, c is less than 0, It is not required to take this way actually. What are the things I discussed? This is the case 2. C is equal to 0 and C is greater than 0. We have to take this 3 point. But the most important thing is we have to check at the given point. That is most important. Now here also the same thing. We have to check the continuity at x equal to 0. Here find all point of discontinuity. Whenever the question is coming all point of discontinuity, then we have to check like x is greater than 0, x is less than 0, and x equal to 0. Okay, only if the question is telling find the discontinuity at the particular point 0, then we have to take like this. Limit x tending to 0 plus 0 plus, that is this is the function definition. The function definition is -1. Limit x tending to 0 minus fx, if we will take, then this is x by minus x, this is -1, and f of 0 value is -1. So the all the value are same, so the function is continuous. Okay, so the function is continuous. So first of all, we have to define all the value here. Fx equal to -1, x is less than 0, x is greater than equal to 0, that is -1. So this is the first function we have to define here. Fx equal to -1 for all x belongs to R. Now limit x tending to c of -1, that is -1 at a given real number. So f of c equal to -1. So function is continuous. Find all point of discontinuity where f is the defined. Now, if we will, first of all, we have to check the point 1. After that, 1 minus, if we will check, then this is continuous. 1 plus, if we will check, 1 plus, this is continuous. 1 minus, this is continuous. But at the particular point 1, we will check, then here we can check 1 plus fx. So we can write here limit x tending to 1 plus. 1 plus value definition is nothing but x plus 1. Just we have to substitute the value, then this is 1 plus 1 equal to 2. Similarly, limit x tending to 2 minus fx, if we will take, 1 minus if we will take, then here limit x tending to 1 minus. So 1 minus definition is x square plus 1, and if we will substitute the value here, then 1 plus 1 is equal to 2, and f of 1 value, if we will check, then f of 1 function definition is x plus 1, this is also 2. So this is nothing but the continuous function at the particular point 1. In this way we have to check all the points. So just you can just see the given function f is defined at all the points of the real line. Let c be a point on the real line. Now when first case we have to check c is less than 1, so the function definition is nothing but c square plus 1, we can write here, and limit x tending to c, the function definition is x square plus 1, directly we have to write c square plus 1. So in this case the value is definition is this is equal, so f is continuous when for all points x is less than 1. Similarly, case number 2, if you'll see at the particular point 2, that already we find out at the particular point 2, the value of the function is first is 2, after that again 2, and again 2. So all the function value, this is left hand, this is right hand, and at the particular given point all the values are same. That's why the given function is continuous. Now third, if the point we can take c is greater than 1, then c is greater than 1, this is the value x tending to c fx, limit x tending to c, this is the value is given, that is also c plus 1. So in this case there is only one definition, so for that x tending to c we can take, that is equal to f of c. So function is continuous all point of x such that x is greater than 1. Clear? Question number 11. Find all point of discontinuity. Wherever the question all point of discontinuity is written, so first of all you have to check at the particular point 2. After that 2 minus, because there is only one single definition, and 2 plus, there is only single definition. So first of all, we have to check at the point 2. So limit x tending to 2 plus fx we will write here. So this value is limit x tending to 2 plus. So 2 plus, what is the 2 plus? That is in the real line when 2 plus it is greater than 2. What is the definition? X square plus 1. So once we will substitute this value, this is 5. Similarly, we can write here limit x tending to 2 minus fx. If we will write here x tending to 2 minus, and we can write x cube minus 3, and this is nothing but if we'll substitute 2 here, this is 8 minus 3 equal to 5, and f of 2 if you will find out, and this is called RHL limit, this is LHL limit, and f of 2 exactly this is equal sign, so f of 2 is nothing but x cube minus 3, this is also 5. So at the particular point 2, the function is continuous. Correct? The particular point 2, the function is continuous. So 2 minus, if we will check. Now first 2 minus. For that we have to take one point C. For our reference, we will take one point C on the real line. Now C is less than 2. So f of C, we can write this limit x tending to C fx. So this we can write, because there is only one single definition of the given function. So the both value at the particular point C and limit value both are same. So this is same. So function is continuous at the particular point C is less than 2. Now C equal to 2, already I discussed, all the value are 5. Now C is greater than 2, definitely there is only single value. So f of C is equal to C square plus 1, and x tending to C, if you will take, this is also single value, so C square plus 1. So both value are same. So f is continuous for all point of x is greater than 2. Now in this case also same thing. So find all point of discontinuity. For the point 1, exactly we have to check limit x tending to 1 plus. 1 plus value definition is x square, directly I am writing, and this value once we will substitute, this is 1. And limit x tending to 1 minus, so this value is x square minus 1. So once we will substitute, this is 1 minus 1 is 0. So definitely at the particular point 1, the given function is not continuous. But when x is less than 1, definitely this is continuous, and x is greater than 1, then definitely this is continuous function. So we have to check. Let's see any point on the real line. So C is less than 1, and there is only single definition. So f of C is c to the power 10 minus 1. So this value limit x tending to C fx, this is c to the power 10 minus 1, and this value is, so f is continuous at all point when x is less than 1. Case 2, C is equal to 1. Already we got the value, the f of 1 minus, and this value is 0, this value is 1, and definitely 1 plus and 1 minus, both limit is not same, so definitely this is not continuous. And case 3 we have to take when C is greater than 1. So f of C is, the according to the definition, this is C square, and limit x tending to C fx, x tending to C x square, we can write here C square. So both value are same, so f is continuous when x is greater than 1. Now question number 13 is the function is defined by fx equal to this x plus 5, x minus 5, x is less than, x is greater than 1. Function is continuous. Now here we have to check the function is continuous or at the particular point x tending to 1 plus, we have to write like this. So limit x tending to 1 plus, if you will write, then this is nothing but x minus 5, and this is minus 4. And limit x tending to 1 minus fx equal to limit x tending to 1 minus, definition is x plus 5. So if we'll substitute, this is 6. So definitely the both value are not same. So function is not continuous. Correct. So C is less than 1, C equal to 1, and definitely less than and greater than, there is only single definition of the given function, then that the particular point that is continuous, C is less than 1. But at the particular point, if we will check, so this is 6 and minus 4 that we discussed, and this is not, this is the value 1 minus, the value is coming 6, and after that 1 plus value, this is coming minus 4. Both are not coinciding to each other, both are not equal, so definitely the given function is not continuous at all. C is greater than 1, one definition, only one definition at the particular point, also we can say one definition, and after that C is greater than 1, there is only one, so this is continuous function. Now in this case there are 3 points are there. First is 1, 3. There are 2 points are there. There we have to check the continuity or not. Now, first of all, 0 to 1, if we will check, then this is continuous. C equal to 1, then one value is 3, another value is 4. Definitely this value is not continuous at x equal to, that is C equal to 1. So do not coincide. Case 3, 1 to 3, the value definitely in this case the function is continuous, all the points from 1 to 3. Now fourth, if C equal to 3, then FC equal to 5, and their value 3 minus value is 4. So both value are, so, and right hand limit value is 5. So both are not coinciding to each other, left and right hand value are not equal, so they are not continuous. Question example, case number 5, in this case 3 to 10 if we will take, then there is only single definition, that is 5, and this is 5, so this is continuous. In this case also we have to do the same, 0, 1. So 0 plus this function is continuous. Suppose the point C we will take, then this is the value which is less than 0, the value definitely continuous. But at the particular point 1 and 0 we have to check. So limit x tending to 0 plus, if we will take the function definition is 0 only, but limit x tending to 0 minus, if we will take this is 2x and this is 0, so both value are same. This is RHL value and this is LH value, both value are same. So LHL equal to RHL, and that is equal to f of 0, if we will find out, that is equal to 0. So in this case, this function is continuous at the particular point 0. But what about the 1? If we will take 1, so from here only you can check 1 minus the value is 0 and 1 plus value is 4. So in this case, that the function is not continuous. Now, you can see here, case number 1, C is less than 0. So the function definition is 1. So definitely it is continuous for all point. Now case number 2, when 0, so in this case, both value left hand limit and right hand limit, both value are equal. So this and this both value are equal. So definitely this is continuous. Now 0 to 1, if you will take, definitely one single value, that is 0, and in this case function is continuous at all point between 0 to 1. At the point C equal to 1, if we will see, then first value is 0, 1 minus, this is 0, and 1 plus value is 4. So definitely this is discontinuous. And C is less than 1. So in this case, there is only one single definition. So definitely limit x tending to C, fx equal to f of C. So continuous for all point x is greater than 1. Now discuss the continuity of the function f minus 1. This is the same question. So just I am moving forward. Just you can match. C is less than minus 1. Definitely continuous. C equal to 1. So both value are same here. both value are same here, that is minus 2 and c equal to minus 2. Definitely this is continuous at x c equal to minus 1. Now minus 1 to 1, there is only one single definition, that is f of c equal to 2c, and this is the single definition, that is 2x. So in this case, definitely this is continuous for minus 1 to 1, and c equal to 1, if we will check, then this is also the both value are same at the point c. This is 2, 1 plus, that is also 2, and 1 minus, 1 minus is also 2, and 1 plus is also 2. So definitely this is continuous. And c is greater than 1, same, c is greater than 1, we can say this is single valued function, that definitely this is continuous. Now, find the relation between a and b so that the function is continuous. Always remember, when we have to find out any unknown value, so in that case, the given function should and must be continuous. So at the particular point 3, the function is continuous. So here we can write limit extending to 3 plus fx equal to limit extending to 3 minus fx equal to f of 3. We can take, because this is the 3 point we have to check. So 3 plus definition is what? X is greater than 3, that we can write here limit extending to 3 plus, that is bx plus 3, and 3 minus value is ax plus 1 and f of 3. So equal value is ax plus b f of 3, that is 3a plus 1. So after that, just we have to substitute the value. This is 3b plus 3, 3a plus 3, that is equal to 3a plus 1, and we have to solve the linear equation and get the answer. So just you take 3 minus f of 3, 3 plus 3a plus 1, 3b plus 1. So f of 3, all the functions are continuous, so we can write here like this. And once we solve, a equal to b plus 2 by 3, this is the value, and a equal to b plus 2 by 3, this is the required relationship between a and b. Find the value of lambda, the given function, continuous at x equal to 0. What about continuity at x equal to 1? Definitely there is only single definition at x equal to 1. This is greater than 0, so this value we will take for this, and this is continuous. Now if it is continuous at x equal to 0, then we have to find out the value of lambda. So same way we can find out limit extending to 0 plus and 0 minus. Here we can find out 0 minus, function definition limit extending to 0, f of 0. If we will substitute the value lambda x square minus 2x, this is 4x plus 1 equal to 0. So 0 equal to 0, which is not possible. So there is no value of lambda from which the given function is continuous at x equal to 0. So f of 1 we can find out, f of 1, this is 5, 4x plus 1, this is also 5. So limit extending to 1 fx. So function for any value of lambda, f can be continuous at x equal to 1. So this is the, for any value of lambda, f is continuous at x equal to 1. Now question number 19. So that the function x minus greatest integer is discontinuous at all integral point. So first of all, this is nothing but the x minus greatest integer is nothing but the fraction part of x. So when we are drawing the graph of this one, and the value of the fraction always lie between 0 to 1. 0 to 1. So 1 is not including, that's why just I'm drawing the graph, and this is minus 1 to, this is minus 1 0 1 2 minus 2. So the graph is coming like this. So in this case you can check this, all points are not including, so all integers point, this is discontinuous. From the graphical way we can prove like this. But we can check here gx equal to x minus greatest integer. G is defined for all integral point. Suppose we are taking one integer n. So for the integer n, we can take g and n minus greatest integer, that is equal to 0. Now, for the left hand limit, we can take limit extending to n minus, and this value limit extending to n minus, this we can write here x, and this is greatest integer, and n minus, the function of the greatest integer is actually n minus 1. So once we'll solve, this is n equal to 1. So x equal to n, the particular point we want to check, the right hand side limit. So limit n tending to gx, x tending to n plus. So limit x tending to n plus, function definition, first of all we have to take the x and we will substitute the value of n, and after that n plus greatest integer function is nothing but the n. So this is the very, very important thing. X tending to n minus, function definition is n minus 1, and n plus, this is n. So once we'll solve, this is equal to 0. So left and right hand both value are not equal, so definitely this is not continuous. Is the function defined by is continuous at x equal to p? We have to check. It is even it, so we have to check x equal to p. So x equal to pi. So if we will check x equal to pi, the value of the fx is nothing but f of pi. So this is pi square plus 5. Pi square plus 5. After that, x tending to pi we want to check. So for that, we have to substitute x equal to pi plus h. So x tending to pi, then x tending to pi. So this is pi equal to pi plus h. So pi will cut. So in this case, we can write here h tending to 0. So h tending to 0. So limit x tending to pi fx, we can write here limit x tending to pi. This is the given function. So after that, we just by substitution, we got h tending to 0. So in place of x, there is pi plus h, sine pi plus h plus 5. So after solving this, we are getting the value pi square plus 5. So pi plus h whole square, pi plus 0 whole square. So sine pi plus h, and this is constant value. So sine a into cos b plus cos a into sine b. Here we have to extend the value, and limit h tending to 0 sine pi into cos h minus limit h tending to 0 cos pi minus this is sine h. So this is pi here. After substituting all the value, this is the numerical value we get, and this is nothing but pi square plus 5. So this is the value after doing the substitution, x equal to pi plus h. So function, definitely there is only one single definition function. So for pi plus and pi minus, both value are same. So that's why we got only one value, and this is nothing but the both value are same. So this is continuous. Discuss the continuity of the following function: sin x plus cos x, sin x minus cos x, sin x into cos x. So whenever the two trigonometric function is there, g and h are two continuous functions, then g plus h is also a continuous function. This is very, very important theorem. This we have to remember. Suppose two functions, g and h are two continuous functions, then g plus h, g minus h, and g into h. This is also a continuous function. Now, gx equal to sin x and hx equal to cos x. So gx equal to sin x. So definitely this function we want to prove. It is, so gx equal to sin x. So it is defined for every real number. So C be a real number, put x equal to c plus h. X tending to c, h tending to 0. So this is the very, very important substitution we have to do. Now x tending to c, h tending to 0. So g of c equal to sin c. Limit x tending to c, g x equal to limit x tending to c, sin x. After that, here limit h tending to 0 sin c plus h, limit h tending to 0, sine A into cos B plus cos A into sine B, and this value is sine C. So limit x tending to C, gx equal to gc, so this function is continuous. And we will check hx equal to continuous or not. Definitely this is also a continuous function. So hx equal to cos x. So c be any real number, then we have to put x equal to c plus h, x tending to c, h tending to 0. So this is the very important substitution we have to do. So hc equal to cos c, and we have to find out the same way. So limit x tending to c, hx equal to hc. So h is continuous function. So both are continuous, and according to the definition, we have to prove that this three important thing. If gx and hx are continuous, then sum, difference, and product all should and must be continuous. Discuss the continuity of the cosine, cosine, secant, and cosine function. Now question number 22. Discuss the continuity of the cosine, cosine, secant, and cotangent function. Now already we discussed here the most important theorem. Suppose the function hx by gx, so denominator should not be equal to 0. This is a continuous, but gx should not equal to 0. Here also 1 by gx should not equal to 0. It is a continuous function. And 1 by hx, this is also not equal to 0. It is a continuous function. So this is the reciprocal function is continuous except the particular point where gx is 0. Okay. So gx should not be equal to 0. This is only the condition. Now already we proved sin x and cos x function. Already we proved these both are continuous function, and gx equal to sin x. What the process we follow? X equal to c plus h. So x tending to c, then h tending to 0. X tending to c here, cc will cut, and h tending to 0. In this way we can find out. Now x tending to c, h tending to 0. Similarly, gc, we can write here limit x tending to c, gc, and just we have to expand, and we got sin c. So limit x tending to c, gx equal to gc. Similarly, already we proved cos x function, already we proved this is continuous. So for that we have to substitute the value, and here also we have to follow the same process. ht, limit x tending to c, hx equal to, and this is the limit hx function is nothing but the cos x, and in place of cos x, x tending to c, then h tending to 0, c plus h. So just we expanded this and we got the value cos c. So limit x tending to c, hx equal to hc. This is continuous function. Now we have to find out cosec x. So cosec x we can write here 1 by sin x, where sin x is not equal to 0 is continuous. That means cosec x, and this is not equal to 0. That means if sin x equal to 0, then x equal to n pi. This is not equal to 0. That means x is not equal to n pi. Simple. So in this case, this is continuous, for this is the condition. Similarly, cosine function is continuous except x equal to np. And sec x 1 by cos x we can write x is not equal to, suppose cos x equal to 0. So in that, from the trigonometry, x equal to 2n plus 1 into pi by 2. So here not equal to 0. That means we can write x not equal to 2n plus 1 into pi by 2. This is condition of continuity. So second is continuous except this particular point. Cot x equal to cos x by sin x, and sin x is not equal to 0 is continuous. So cot x is continuous except x equal to n pi. So this is very important. This theorem you have to remember, whatever the reciprocal function. Find the point of discontinuity of the function. So for that we have to check the continuity at x equal to 0. So limit x tending to 0 plus, if you will find out function definition is fx. So this is x tending to 0 plus we can write here x plus 1. So this is 1. So limit x tending to 0 minus fx, if you will write, then this is x tending to 0 minus. 0 minus is sin x by x. Sin x by x. This is also 1. And f of 0 value is nothing but f x plus 1. This is also equal. So all values are same at x equal to 0. So definitely the given function is continuous. Now we have to check. Suppose we will take in the real number, we will take CBA, any real number. So in that case, c is less than 0. So directly we can write f of c, that is sin c by c, and limit x tending to c fx, we can write sin c by c. So this particular less than, the function is continuous. X is less than 0, it is continuous. X equal to c is greater than 0, there is only one single value, that's why this is continuous. And third point, we have to check already, c equal to 0, then first value is 1, second value 0 minus is also 1, and 0 plus also equal to 1. So all the value are same. So this point is, it is continuous. Now there is no any point of discontinuity. Now same, determine if x is defined by, now continuous or not. First of all, I will find x is not equal to 0. There are two cases, x is greater than 0 or x is less than 0. So limit x tending to 0 plus, if you will find out, so function definition is same, x square sine of 1 by x. So once we will substitute here, just this is very, very important. Once we will substitute here, this is 0, but 1 by 0 is not possible. The range of this is always lie between -2, 1 to 1, and this number is 0. So this value is always 0. Similarly, limit x tending to 0 minus, if you'll find out, x square sine 1 by x. So this value is always lie between -1 to 1, and this is 0. So this is 0. And at the point x equal to 0, the given function is 0. So left hand, this is right hand limit, and this is left hand limit, and at the point 0, all the value are same. So definitely this is continuous function. Now when we will take any number c is less than 0, c is greater than 0, if we will check here, so this is c not equal to 0. This is the case already we discussed. C equal to 0. So c is not equal to 0. The value of the f of c is this value, f limit extending to c fx, limit extending to c x square sine 1 by x. So x square sine 1 by x, we can write here c square sine 1 by c. So both value are same. Now, so function is continuous at all point except x equal to 0. Now, case number 2, x equal to 0, if we'll check, then fx 0 minus, so 0 minus x square sine 1 by x. So we can write here x square sine 1 by x. We know the sine x value lies between -1 to 1. So just we have to write minus x square to x square, we have to multiply by x square both sides. So here also x square will come. So this value x square, and limit if we will take all the sides, so this is 0, this is 0, and the value x square sine 1 by x, this value is equal to 0. Similarly, we can find out for the 0 plus also 0. So definitely this function is continuous at x equal to 0. Examine the continuity of the function. It is the same type of question. First of all, 0 minus and 0 plus, we have to, x is greater than 0, x is less than 0, function definition is same, and x equal to 0. If all the values 0 plus 0 minus and x equal to 0 are -1, then only it is a continuous. So we can check here. We take one real number c. Now first case, c is not equal to 0. C is not equal to 0, then the function definition fc, we can write here this limit x tending to c fx. So this is the value, this is nothing but sin x minus cos x, both are Same, definitely f is continuous at all point when x is not equal to 0. But the case 2, when c equal to 0, so f of c equal to 0, so f of 0 equal to -1, 0 minus, this is a -1, and 0 plus, this is also -1, all value are -1, then definitely this is continuous. Now, find the value of k so that the function is continuous. So in this case, only one thing we know, if it's continuous, then we have to find out limit extending to pi by 2 fx equal to f of pi by 2. Because x is not equal to pi by 2, the meaning is pi by 2 plus and pi by 2 minus. Both value are same. Correct? Both value are same. So in this case, we can find out easily. We have to find out the limit. So just we have to evaluate. Just this is the way of evaluation of the limit. So in this case, we have to substitute the value x equal to pi by 2 plus h, x tending to pi by 2, then h tending to 0. This is very, very important step that we have to follow to solve this problem. Now x tending to pi by 2. So this is the value x tending to pi by 2 fx, limit x tending to pi by 2, this is the value. So limit h tending to 0, k cos pi by 2 plus h minus 2. After solving this will cut and this value is coming k by 2. So k by 2 and k by 2 is given, f of pi by 2 is given 3, that k equal to 6. Now same, find the value of k for the given function. So in this case, it's easy. So limit x tending to, in this way easily you can find out x tending to, so this value is x tending to 2 plus value is nothing but 3. This is fx equal to 3. So this is 3. So limit x tending to 2 minus fx. So limit x tending to 2 minus function definition is k into x square. So just we have to substitute the value of x. So this is 4k. And we know this f of 2 equal to, if we have to find out f of 2, this is nothing but k into 2 square. This is 4k. Now we know this is continuous, so we can write 2 plus fx equal to f of 2 directly. This is 2 plus 2 minus is not required because continuous, it is already continuous. So this is nothing but 4k and this value is 2 plus value is 3 and this is equal to, so limit x tending to 2 plus and 2 minus and f of 2, both value we have to equate. So limit x tending to, suppose you write here 2 plus and after that, just a moment, after that you can write here limit x tending to 2 minus fx equal to f of 2. F of 2 value is 4k. 2 minus value, if we already find, that is 4k and this is 3. So any two value we have to equate and k value is 3 by 4. In this way we can find out. So this type of question is easiest question. So this is the value k equal to, just we have to find out the value and already we got the value 2 minus 2 plus f of 2. Because this is continuous, so we have to just substitute the value and we got 4k equal to 3 and 3k equal to 3 by 4. Find the value of k so that the function is continuous. Same way we have to do. We have to find out the same way. Limit x tending to pi minus fx, pi plus fx, and that is equal to pi. Limit x tending to pi minus, the function definition is this. Pi plus, this is the function f pi k pi plus 1. So k pi plus 1 cos pi, any one value, we have to solve this. So k pi plus 1 equal to cos pi is equal to minus 1. So k pi plus 1, and once we will solve, this value is k equal to minus 2 by pi. So this type of question we can solve like this. Find the value of k so that the function is continuous. It is the same. Just we have to find out x equal to 5. This is the function definition. K x plus 1. So this is only the single step problem. That's why I'm coming here directly. And this is the first you have to write down the condition. Limit extending to 5 minus, this is the value. 5 plus, this is the value, and 5k plus 1. So after solving this, we are getting 5k equal to 9, k equal to 9 by 5. Find the value of a and b so that the function is defined by this is continuous. So in this case, there are two value and two unknown are there. Now, two unknown a and b we have to find out. So we have to check limit extending to 2. So we can write here limit extending to 2 plus fx equal to limit extending to 2 minus fx equal to f of 2. And here we can write limit extending to 10, this value, 10 minus fx equal to limit extending to 10 plus fx equal to f of 10. So 2 plus value is nothing but ax plus b. So here we can write limit extending to 2 plus is nothing but ax plus b equal to limit extending to 2 minus value and 2 equal to both value are same. So we can write here this fx equal to f2 but both value are same. So just you substitute here and this we can get 2a plus b equal to 5. Similarly here we can find out 10 plus and 10 minus. So 10 minus definition is limit extending to 10 minus ax plus b and 10 plus and 10 both value are 21. So just you substitute here 10a plus b equal to 21. In this way we can find out 2a plus b and 10a plus b equal to 21. Just solve a and b, we will get. Just you can check here 2a plus b, this is the first value, and 2a plus b equal to 5 that we discussed. Now similarly f is continuous at x equal to 10. So 10a plus b, just by solving these two we get a equal to 2 and b equal to 1. So this is the value of a and b. So that the function fx defined by fx equal to cos x square is continuous. Now the most important thing is this type of function is function inside the function. This is called the composite function. This is called the composite function. F is defined for every real number and f can be written as the composite of two functions. We can write here. Now f we can write here GOH. That is g is nothing but gx is first function is cos x and hx we can write here x square. So in this two function, that is we are writing first function as a cos x and another we are writing x square. So g of h, we will read g of h. So g of h x we can write GHX. We can write here g of hx. We can write here g of hx. Just you can see here. Now hx value is x square. First we have to write, and after that g of hx we have to substitute here the value g of x square. So gx value is this. So once we will substitute this in place of x, just you have to substitute x square, and this is cos x square. This is equal to f of x. So it is equal to given function f of x. So gx equal to cos x and hx equal to x square is continuous function. So definitely g is defined for every real number. Every real number. Now let c be a real number. So gc equal to cos c we can write here. So just we have to substitute x equal to c plus h, x tending to c, h tending to 0. So we have to prove this is cos x. Cos x value is this is equal to g of x equal to cos c. So g of x equal to g of c. So gx And already we know this is continuous function. Same way we have to prove this is also a continuous function. So both function we have to prove this is a continuous function. So for that hk equal to k square, and same way we have to prove h is also a continuous function. So it is crystal clear GOF is continuous at x equal to c. So GOHX, that is cos x square, is a continuous function. In this way we can prove. Similarly, mod of cos x we have to prove. Question number 32. So that the function mod of cos x is continuous function. So this type of function is function inside the function, that is called composite function of two function. That is nothing but the composite function of two function. So g of, we can write this GOH, that is nothing but the f of x function. We can write here g of x is nothing but modulus function, and h of x is nothing but the inside cos x. After that, GOHX we can write g of hx. Hx value is cos x, and just we have to substitute here. So see, g of cos x is nothing but the mod of cos x, and this is called way we can find out the composite function, that is equal to f of x. Now we have to prove that whatever the gx and hx we took, that is also a continuous function, and we know same way we can prove what the question we solved earlier. So gx is modulus function, and modulus function, first of all we have to define x is less than and x is greater than, and we can find out this is a continuous function, and definitely this is a continuous function because limit extending to 0 plus is x, this is 0, limit extending to 0 minus, this is 0, and f of 0 is also 0. So definitely this is a continuous function. So case 1 we will see. So in the case 1, c is less than 0, then there is only one definition of the given function. So definitely this is continuous. X is less than 0. So g of c equal to minus c, and g of limit extending to c, g of x equal to also minus c. So already we saw whenever we are looking only one definition of the function, then that is continuous. C is greater than 0 is also a continuous. Now at the point c equal to 0, we checked this is 0, this is the value is 0, limit gx minus x value is 0, gx, that is x equal to 0. So 0 plus 0 minus and g of 0, all the value are 0. So this function is nothing but the continuous. So from the above observation, it can be concluded that g is nothing but the continuous at all points. Similarly, hx we can check, already we discussed earlier. So sin x is also a continuous, already we shown this process. So just you can check already. The previous question also we saw. So h of c equal to sin c, h of c equal to sin c, limit extending to c, h of x. So limit extending to c sin x. After that, just we have to substitute h tending to 0, and in place of x, c plus k, and expand the value of sin a plus b format, and we got hx equal to g of c. So hx is also a continuous function. So f of g, form of x function, is a continuous function. So that's why we can write here f of x, g of hx, that is nothing but the mod sin x is a continuous function. So this is the way we can prove any composite function. We can prove how this continuity of the given function. Find all points, question number 34, find all point of discontinuity of the given function, and both are modulus function. So two function fx and hx we can take here, f gx and hx. So this is mod x plus 1 and this is mod x. So f equal to g minus h. So continue the continuity of g and h is examined first. After that, so this is modulus function, already we checked this type of function. How we checked? Already we took one value, and after that there are three cases. C is less than 0, for that one single function continuous. C is greater than 0 and c equal to 0, for that also we have to check. So c is less than 0, so limit extending to c, g of x equal to g of c. C is greater than 0, this is also a continuous function, and at x equal to 0, that is c equal to 0, the given function is continuous. So 0, 0, all are 0. So this function is continuous. So from the above three observation, it can be concluded that g is continuous at all points. Similarly, we have to find out h of x, that is mod x plus x 1, and here once we want to define x plus 1 equal to 0, x equal to minus 1. So when x is less than minus 1, this is minus x plus 1. X is greater than minus 1, this is x plus 1. So in this way, c is less than 1, function is continuous. C is greater than minus 1, function is continuous. So just we have to write this is the value h of c, this is the value. After that, limit extending to c, we have to find out this both value are same. Now we have to find out case number third, that is c equal to minus 1. So this value is 0. C of minus 1, this is 0, and minus 1 plus this is also 0. Just we have to substitute the corresponding value of hx, and 1 plus hx value is x plus 1, and this is also 0. So 1 minus 1 plus an h of 1, this is value is continuous. So from the above three observation, we can conclude that h is continuous at all point. So g and h are continuous functions. So f equal to g minus h is also a continuous function. So this way we can find out all the continuity of the composite function. So I hope this is crystal clear for all of you. Just you do the practice and command on this topic. Thank you.